Okay, let's see if I can get this a little bit. Okay, so we're going to do some meeting level solving. I got a couple different problems on here. So what we're going to do, first thing we want to do is isolate the radical. That is our first step. So on this one, to isolate the radical, I'm adding 4 to the radical, so I actually need to subtract 4. And then what I want to do is find the 4th root of 2k minus 5 is equal to negative 4. And then what we want to do is we want to undo the radical. So we're going to take everything to the 4th power, and we get 2k. This undoes that. We get 2k minus 5 is equal to 4th power, 256, I believe. Let me make sure. It's been a long day, so yeah, I'm right. Okay, and then we're just going to solve for k. So we add 5. And we get 2k is equal to 251. We divide by 2, we divide by 2. And we get k is equal to positive 251 divided by 2. Then what we have to do is we have to take our calculator, and we're going to have to check that. So what I'm going to do is to prove it on my test, to check my answer, I'm going to write the 4th root, 2 times 251 divided by 2 minus 5. Plus 4, we need to make sure that equals 0. So we're going to put that in our calculator. We're going to go to math. We're going to go down to the 5th option, which is going to give us that. Then we're going to put the 4th root of 2 times 251 divided by 2 minus 5. And then outside the radical, we're going to put plus 4. And we do not get 0. So this, no solution. And here's also something we could have done at the beginning. When we subtracted the 4, we got the 4th root of 2k minus 5 equals negative 4. This is an even degree, or even index. My root is an even number. It's the 4th root. It can never equal a negative number in the real, if we're in the realm of all real numbers. So, because that's true, then we're done. We could have stopped right there, but no solution. But if you want to make sure and you're nervous about the test, go through, just make sure you plug it back in. Okay, this one, it's a lot like the other one, except this is odd. So we can isolate the radical, and this time we're adding 2 to this cubed root, so we're going to subtract 2. Now this one, even though I just told you something kind of neat, this is odd, so it can equal a negative number, so we could probably get a solution. So now we want to cube both sides, so we end up with x minus 8 is equal to negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. And then we're going to add 8 to both sides, and then we're going to get x is equal to 0. Then we're going to plug that in. And this says, now, so we're going to write the cubed root of 0 minus 8 plus 2 equals 0. We're going to make sure that's true. So we're going to go to our calculator. We're going to go down to the 4th option, which is our cubed root. We're going to type 0 minus 8 plus 2, and we get 0. This solution does work. So that is the solution. Okay, this one, we want to isolate the radical. Well, the radical is already by itself. This is a square root, so we can square both sides automatically. I'm squaring a binomial. I know it's a binomial because I got 2 terms that's separated by plus and minus. So I'm going to end up with 9 minus x is equal to, now this is a binomial. We typically put it in a box. I'm not going to do that, but I'll go ahead and do that. Let's see. I don't know why I wrote it backwards. Probably because I'm not going to do the math. There we go. So then we end up with x squared plus 6x plus 9. Make sure your box says that. And now I have a quadratic. Quadratics have to equal 0 in order to solve. So I'm going to subtract 9 and add x minus 9 plus x. And I'm going to get 0 is equal to x squared. 6x plus 1x is now 7x. 9 minus 9 is 0, so I don't write anything. And now we factor. Well, I only can do a GCF here. So I could pull out an x out of both of those, and I'm going to end up with that. Then to solve factoring, you set each factor equal to 0, and you solve. So I set this one equal to 0, and then x plus 7 is equal to 0, and you solve, and you get negative 7, and then we got to plug them back in. So what we need to do is we need to get the square root of 9 minus 0 for the first one, and we're going to get 3. If I plug in a 0 here, I get 3. So this one works, that one works. So, oops, 0. No, 9 minus 0 equals 3. That's perfect. And now we need to check the next one, which is negative 7. So the square root of 9 minus negative 7 is going to equal negative 7 plus 3 is negative 4. So we're going to get the square root of 9 minus, I'm going to put the negative 7 in parentheses just to make sure I get it right. And I'm looking for a negative, oh, that's positive 4. Nope, that one does not work. Extraneous, that is the only solution. Okay, let's see, I have another one. What's next? Okay, here is an advanced level question. So the first thing we have to do is isolate a radical. There's 2 of them, so I can only isolate one first. So I like to isolate the second one purely out of just laziness. It's easier just to move this one over. So I'm going to add the square root of r minus 2 to both sides. And then I end up with r plus 6. The square root of r plus 6 is equal to 2 plus the square root of r minus 2. Now I can take this one and I can square this. Oh, but I've got a binomial. So just like over here, where I had 2 terms, an x and a 3 with a plus in between, I've got a 2 and a square root of r minus 2 as a binomial. So while this does cancel out and we're going to end up with r plus 6, I have to figure out what that is. And typically, we're going to use a box for that. So I like to keep my numbers right next to each other, so I put the 2 and the 2 there. I put the square root of r minus 2, square root of r minus 2. Now I just do the multiplication. 2 times 2 is 4. 2 times square root of r minus 2 is 2 times r minus 2. 2 times square root of r minus 2 is 2 times square root of r minus 2. And then this right here is the square root of r minus 2 times the square root of r minus 2, which is just the square root of r minus 2 squared. So I just end up with r minus 2. Then we write equals. I typically put everything in here. So we want to combine any like terms. So those are like terms. So 2 plus 2 is 4. So we're going to end up 4 times the square root of r minus 2. I've got a 4, and this just says r minus 2. So I could really put all of this together. So I'm going to get r minus 2 plus 4. Negative 2 plus 4 is just 2. So I end up with r plus 2. So plus r plus 2. And now I can start rearranging. So now I want to isolate this radical. So I'm going to subtract an r and subtract a 2. Subtract an r, subtract a 2. And these cancel out, and I'm just left with 4 equals 4 times the square root of r minus 2. And I want to get this, so doing the division here is going to make this problem easier. So I'm going to divide by 4. Doesn't always, but it does here. This turns into a 1. This turns into a 1. So I get 1 is equal to the square root of r minus 2. Then I'm going to square both sides to break that out. I get 1 is equal to r minus 2. Add 2 to both sides. And I get r is equal to 3. So now I just have to go back here and plug it in. So I'm going to get the square root of 3 plus 6 minus the square root of 3 minus 2. And is that going to equal 2? So the square root of 3 plus 6 is 9 minus the square root of 3 minus 1, or 3 minus 2 is 1, equals 2. Square root of 9 is 3. Square root of 1 is 1. So then we get 3 minus 1 equals 2. That does work. Check the solution, we're good. And that, my friends, would be worth 6 points. Okay, if you have any questions, ask me tomorrow. Otherwise, I will see you tomorrow during the test. Have a great day.